Hey, what's going on everyone? Welcome back to the channel. In this video, we're kicking off a brand new series focused on writing exploit code for web applications in Python. Throughout this series, we'll be working through labs and challenges from Hack the Box and Portser Academy, breaking down the vulnerabilities and understanding the root cause, and then developing a Python script to solve the challenge. The series is going to cover things like authentication bypasses, server-side template injection, SQL injection, deserialization, and a bunch of other common web vulnerabilities. But the main focus here isn't just solving the challenge, but learning how to think through exploitation and building a reliable proof of concept code in Python. So whether you're prepping for certifications, getting into offensive security, or just trying to level up your Python development skills, hopefully this series teaches you something useful. In today's video, we're going to be taking a look at templated from Hack the Box. We'll walk through the vulnerability, map out the attack, and build an exploit code from scratch together. With that being said, let's get started. So I have the templated lab pulled up and it's running in Firefox. I have Burp Suite running, so let me just test to make sure that looks like it's good. And I'm leveraging Visual Studio Code to create my Python proof of concept or exploit code. And I'm in a directory called exploit script. So step one, let's find the vulnerability and exploit it. So right off the bat, we do see this is using Flask and the Jinja 2 templating engine. Let's try some basic enumeration. So if we wanted to do, like, view the page source, nothing really value here. If we do robots.txt, that returns a 404, but it reflects the robots.txt. So if we did hello world, that is also reflected in here. So I'm curious about trying things like HTML injection, which doesn't seem to work. We could try doing something like server-side template injection, so 7 times 7, and that does equal 49. So pretty straightforward with this. So it's nice that our first lab or challenge doing this will be pretty easy to identify the vulnerability type. So we're dealing with server-side template injection. We know where we're injecting our payload, so we have something to work off of. So our goal is to send GET request to this application, and this is what we'll construct. All right, I think we're ready to start scripting this out. Our first step is we need to import the request library. This is the library that'll let us send HTTP requests like GET and POST to our target web application. Next, let's set up a foundation and let's specify our target, the IP address and the port, so we can make communications to that. So what we have is a variable for server, and this is taking the IP address of our target, and then a variable for the port, and again, this is the port of the application that we're targeting. And then we're going to use an F string and then say HTTP : our server and then our port. So you can see here, this should reflect our target in our web browser. So next, let's just test this and make sure everything's working just fine. So what this is doing is saying, let's use the request library. We're going to set up a GET to our target URL, and we want to pull back the text from that, and then we're going to print that to the screen. And it looks like it's working just fine. So we send out that GET request, we pulled back some data, displayed that to the screen. So awesome. Let's move on to the next step. This part is optional. However, I highly encourage you to get into this habit. I'm going to set up a variable that stores a dictionary for us to proxy our request into Burp Suite. It'll make troubleshooting and debugging a lot easier for you down the road. So this is what it looks like. Proxies equals, and then we have this dictionary in here, and then we're using HTTP and HTTPS, and then here is the address for Burp Suite. So when we start sending these requests, and I can actually go ahead and start showing this right now. Proxies equal proxies. So before, and I'll go in here and clear everything out. Clear history, so it's completely empty. This is saved. Let me run this again. And you can see we made that request. If we go into burp, it actually made a request in here as well, or it was proxied in here. So again, this is going to be super helpful for debugging and something that you really want to get into the habit of setting up. So next, we have established communication. What if we want to get our basic POC that we had in here, right? So 7 times 7 getting 49. We want to replicate that in here. So let's go ahead and do something like so we have POC, and then we have in double quotes 7 times 7 in our curly braces, so our SSTI payload is set up. Next, we need to just concatenate that on here. So since that slash is here, that should take care of that, and then it should just append this. So let's save this and run it. All right, so 49, so we're making good progress. Let's transform this into something more practical though. Okay, so I'm on Hacktrix and I looked up server-side template injection, and I'm currently on the Jinja 2 side of things. So a lot of good information in here. And I highly encourage you, if you don't have something like this bookmarked, check out hacktrix.wiki. This is an exceptional reference guide. What we need though is a payload to help us with our attack. So I'm going to go ahead and grab this. So this payload, what this is going to do is, as of right now, it's going to hard code a ls command and then display that output to us. So let's copy this. Let's replace this. And now we have an issue because there's double quotes in here. We have to fix this in one or two ways. We can escape these. And now let's run this and let's see if ls works. It looks like it does, and there's the flag. So we're really close to finishing this. I'm not a fan of this approach though. If you like this, that's fine. I'm going to replace these with single quotes though. So I've gone ahead and replaced those with single quotes. I think that looks a little bit nicer. Let's run this again just to make sure I didn't break something. And same output, there's the flag. Okay, our next step is we have this hard-coded in here, so we could do something like this. Let's see if this works. There's the flag, so we do, in theory, have a working exploit. However, I feel like this isn't doing it justice. Let's make this more dynamic. So let's actually swap this out. And up here, let's say who am I? Pass that in here. Now we do have another issue. We can do, I believe, something like this. So we can concatenate the CMD variable here. It still needs to be interpreted to go through as like a string, but in this case, this should take the CMD, whatever we have in here, and place that inside of this. So we are root. So if we change this now to ls, we get the list of items or host name. Just a couple things just to test this out. So it looks like it's fine. Let's change this to an argument we can pass through into the script. So let's import another library called sys. And what this will do is allow us to swap this out. sys.argv, and now we need to make sure we're specifying the index of this. So by default, this is the arguments that we're passing to it. So now we need to, when we run this script, if we don't pass an argument, we'll actually break this. So we need to pass something in here like ls. And we run the ls command. Who am I? Root. So things that we ran before that we know work. So we now have this as a more of a dynamic script, but we need to keep building off of this. So instead of erroring out if we don't provide an argument, let's do this. So what this is doing is it's checking to make sure we provided the arguments for our script. So now if we just run this, it just says, hey, we need to provide a command. So this is checking if the length of the arguments is less than 2, print, this is what we need to do, then exit the program. And then it'll store the argument that you pass into CMD right here. So I think the last few things we want to do is just kind of clean this up a little bit. So let me clear this and let's run this again and see. Okay, ls. So we're getting a lot of information and return like HTML and stuff we don't need. So how can we parse this out? We're going to import one more library. So from bs4 import beautiful soup. And this will help us parse out what we need from the response rather than having to sift through a bunch of HTML. Right now, I would say this isn't super terrible, but we want to make this a lot more better, and this is a library you want to get used to. Just like request, it's something that when you're doing web application exploit development, it's just a library or something that you really want to start learning about and become best friends with. Now that we have the beautiful soup library, let's go ahead and use that down here. So let's say this, soup equal beautiful soup. We're going to pass in that response, and we want to do HTML parsing, just like that. Let's store the output in another variable. So we want to find everything that's located inside of this str tag. And now we just also need to say print output dot text. So again, we have that response. So everything that we currently have in here, we're going to say beautiful soup. Let's make a soup variable. And inside of here, we're going to call beautiful soup, take that response, parse through the HTML, go through the output, find the str tag, store that inside of output, and then just spit out the text. So now if we run this again, all of that ugly HTML is gone. So now we can do something like, who am I? And you just see root. So looks pretty good, right? So I think the last thing we need to do is let's just do ls and the flag's in here. So what if we just did cat flag.txt and it doesn't work? Why is that? Well, it's not going to work because of this issue right here. We need to clean this up a little bit more in order for something like this to work. So let's change this out. So this is going to join all the command line interface arguments into one string. So now we can do something like this, and it will go and get the flag, and we can now run more than just one argument in here. And we can also do like ls tech l and get more information here, host name, things like that. And everything looks like it's working just fine now. So yeah, we're able to grab the flag, and this is what our script currently looks like. So roughly 20 lines, and now we have some POC that we can store and use to exploit this hack the box challenge. So I think this is a relatively easy one to start with to kind of get our feet wet with the idea of what we'll be building on in the future. But here's a few ideas I want you to take away from this and challenge yourself. So we've hard coded the values of server and port in here. Why not make these arguments to provide to the script? We used sys as a means of handling arguments. Look up argparse and see if you can, instead of using sys.arguments, use argparse to create a list of arguments to pass in. And overall, what improvements would you make on this? I feel like this was very rudimentary, very simplistic. It gets the job done. It's something that is easily repeatable to get the exploit to work, but there's a lot that can be improved on it. Tell me in the comments below, what improvements would you make? Would you write this in another language? What other modules or libraries would you use? And how would you build upon this foundation? I'm excited to see what you come up with. Please let me know in the comments below. You have a wonderful day. Happy hacking. Take care.